Okay, let us now look at the case of the moon. We want to look at acceleration due to gravity at the surface of the moon. We already have the mass of the moon. The mass of the moon is 7.35 s/22 kg, and the radius of the moon is 1,737.4 kilometers. And we don't work with kilometer, we need to convert it to meter. Now, looking at this very one, suppose this is the moon. Please don't forget, this is the moon. This is the moon, okay? And don't forget, there's always a weight force. There's always a weight force which is acting, meaning that it must have a weight force, we must have downward. And now we have the gravitational force which is acting upward. Now to consider the net force, to consider the net force there, it means that it's going to be sigma Fy, which is F minus W. Now taking it over, you know that here is 0 because F minus W, and we have our F now to the W, F equal W. Don't forget that our F is gravitational force and with G, and we are looking at the case of the moon. We are looking at the case of the moon. Please don't forget, this one is the case of the moon. It means that it's going to be okay, square all over the square of the radius of the moon. And what is the weight force? Become m, which is the mass of the moon. This one is also the mass of the moon. Okay, G. It means that this will keep one of these. We are going to be having our G to be gravitational constant, which is the mass of the moon, all over the radius, the square of the radius of the moon. The square of the radius of the moon. Let me just bring it to this position. Let me bring it to this position up there. Let me bring it up here. Mean that we are now having our G to be a gravitational constant, which is the mass of the moon, all over the square of the radius of the moon. Mean that this is the formula we are going to use for acceleration due to gravity at the surface of the moon. We have done the one of the Earth. Now we are now in the case of the moon. Now looking at the gravitational constant, please don't forget that our G is always, please don't forget, our G is always 6.67 exponent minus 11. Okay, now what is the mass of the moon? The mass of the moon is simply 7.35 exponent. Okay, let me just bring it here. So that we have enough space. Let me bring it here. Let me bring it to this direction. Okay, we have G using this because 6.67 exponent minus 11 times what is the mass of the moon? The mass of the moon is 7.35 exponent 22. Okay. All over the radius of the moon. Remember, we don't work with kilometers. We need to convert, and we do that. So we are going to have 1.737 or 4, okay, times 10 exponent 6. You also square that. Okay. Now we're not going to use our calculator to resolve this very value. We're going to multiply the numerator. We also multiply the denominator. Please don't forget, there's something I need to let you know for this one of the moon, and there's something I need to let you know. Please don't forget that the moon orbits the Earth. The moon orbits the Earth. They revolve around the Earth. Please don't forget, the moon orbits the Earth, while the Earth orbits the sun. The Earth orbits the sun. Just know the difference between them. The Earth orbits the sun, while the moon orbits the Earth. And it takes 27 days, 7 hours and 43 minutes to go full circle. That will be one of the moon. Please take note, for the one of the moon, it takes 27 days, 7 hours and 3 minutes to go full circle. Okay, now let us see now, multiplying the numerator there, the two value there, let us see with our calculator here, let us see what we have to obtain using our calculator. Okay, okay, from the calculator here, this is what we have. We have 4 points, we have 4.9. Okay, for this one we have 4.90 245. 245 exponent 12. That is what we have there. And now we have the one when you also multiply this one squared. Look at what we have here. We have 3.0. We have 3.027276 exponent 12. This is what we have here. This is what we have. Multiplying the numerator, we have that, which is 4.90 245 exponent 12. And we also square the one, the denominator, we have 3.0276 exponent 12. Now, dividing it, this is what we have. Dividing that two things there, the numerator and the denominator. This is what we have from the calculator. This is what we have from the calculator. We're having approximately, please use your calculator. You are going to have approximately, our G will be what? Approximately, okay, 1.62 meter per second square. This is what we have here. This is what we have. That is the value for G at the surface of the moon. Acceleration due to gravity at the surface of the moon. This is how we obtain the value. This is how we obtain the value. For the one of the Earth is 9.8. For the one of the Earth is 9.8 meter per second square. 9.8 meter per second square, or approximately 10 meter per second square. Now, while the one for the moon now is now 1.62 meter per second square. Thank you very much for joining me on the discussion. God bless you. All the best.